channel. And please give me some comments and subscribe if you like what you see here. Today I'm going to work on my next part for the Beltsander, and it's the tracking roller. I've done a little change in the design from this design here, where I had this tension spring problem over here. I built it all into a tower here instead. Look here at the drawings. Here you see my new drawing, and I've moved the tension spring from here inside this tower, and a handle here can press the tension roller down, and a handle not drawn yet on this side here can tilt the roller here so that it acts like a tracking roller too. So that's a new design, and it's more simple, I think, and easier to implement. So that's what I'm going for. And now I'll focus on making the axle for the tracking roller out of this piece of stock here. Now I prepare for threading the end of the tracking axle, and I set it up here, and I set the machine up for 12mm with a pitch of 1.75, and I should have taken a scratch path here and checked that it's the right pitch. 1.75, yes, and then we take a little cut. Yeah, it'll just start the knot. So now we have to be careful not to take too much. Let's see how it is now. Right on the money. Right on the money. Give it a little. Nice, and it feels nice too. Here you see it really close, and it's a very nice. No cracking, no chatter, no nothing. It's really nice, and it's in stainless steel. I think that's the first time I made it without something cracking and some cracks showing up in the bottom of the threads there. But this looks nice. Now I've set the roller up in the forejaw here, and I'll make it run as true as I can get it here. But I think I would like it to run a little lighter here. It's simply heavy to move. Done. Yeah. And now I'll make a crown and a little wider. I know I have to have the center of the roller around the center of the other rollers, but I can adjust it, even though this here is 70 millimeters and the other rollers is 55. I think I'll have this roller here a little wider. When it tilts up and down, I think there could be use for that. Now I finished the bore for the ball bearing. So, that's nice. Now the problem is when I can do the crowning. I planned now to, while it is still not crowned here, to turn it around and make the other side like this. But then I have to hold it in between center. I'll do the other side in the first place. Yeah. Now I set it up in the lathe and took 16 millimeter all thread rod through here and some nuts here with a cone on the end. There's a little cone there that fits in my seat for the ball bearing, and tightened it loosely, but it's tight, and then lined it up here with the dial and secured that I can get it running as true as I can get it, and that's within 4 or 5 hundredths of a millimeter, so I think that's good enough. And now I'll set up the compound here so that I can slide it parallel this way. And here you see the setup again for this crowning process of this roller here. And I spent the night studying the internet how much to crown the roller. And there's lots of different proposals to how much it is, so I decided to do it my way, and I'm gonna leave 1/2 centimeter in the middle here, not crowned, and then from here to the outer edge of the roller there is I think it's 35 millimeters, no, 30 millimeters. And in this 30 millimeters, I decide that I'll crown it 1 millimeter. So from here to out there, it should be 1 millimeter smaller in radius out here. How can I do that? And the same on this side. How can I do that? I'll place my compound parallel to the axis here. And then I'll simply take a measurement how long I can, depending on how long I can move my slide, cross slide. I'll take a measurement for every 30 millimeters. It should move 1 millimeter inside, and I'll just tilt the compound till I have this degree. In fact, it is a degree, but the way the Russians had made their degree scale over here, it's made with cobblestone, I think. So it's not of any use at all in this. So I'll use the meter here. I don't think you can see it, but I'll use this to, in the first place, I have a machined surface here, and I'll use it to set it parallel to the movement, and then for every 30 millimeters I move it, I'll have to ensure that it moves 1 millimeter in to the one side, and afterwards to the other side, for doing in the first place this one here and the other one there. And that's how it's gonna be. I don't even think it needs to be that accurate, but now I'll do it. So yeah, that's what it's gonna be. I'll set it up now. I can't place the camera so you can see the meter anyway, so maybe it takes a long time, so so I'll just do it and come back when I'm finished. Now I set it up ready to do the crown on this side, and I place the cross slide so that it aligns with my 30 millimeters in from this face here to there. Now it does anyway. And then I'll, with the cross slide here, I'll touch when I start the machine, and then with the compound I'll move this way, and I tilt it a little so that when I come to these 30 millimeters here, I should have 1 millimeter turned off. And I'll take you a little closer so you can see what happens, if anything happens. Oh, I discovered baterias went down just as the fun begins, but I managed to take it off and do a nice little chamfer there. Now I'll set it up for the other side and place you again so you hopefully can see it this time. Now I set it up for the other side, and you should be able to see what's going on from where you stand now. I'll zoom you in a little, if I can. Then focus. Now you should be focused. And I'll start. in the middle here, but I think when the belt has turned around here for a year or so, you'll never notice. You'll never notice. So that's it. Yeah, no, here it is. And I think I can assemble it now here. Yeah. No. And then I'll just need a spacer here to place it on the tower so that the middle is around the middle of the other rollers. So I have to make a spacer here to do that. And then this one here should be mounted in the tilting mechanism so that it can do so. And then you can see there's a little run out in the outer crowning. Just a little, but not much. And I don't know how accurate it has to be. I don't think it has to be so accurate. People out there, some of them just makes it with a file and then by eyeball see how it is. So I think this here will do. And anyway, we have to try it. So yeah, next is the tension spring in the tower and the tower itself and the mechanism that is turning this